In this video, we will introduce the derivative and talk about notation we use for the derivative. This limit of f at x plus h minus f at x divided by h as h approaches 0 plays a central role in calculus. There are two interpretations of this limit. One, it's the slope of the tangent to the graph y equals f at x. Or two, it's the instantaneous rate of change of y equals f at x with respect to x. This is such an important limit that it gets its own name. It's called the derivative of f at x with respect to x. So the derivative of a function, f prime of x, also written as dy by dx, is the limit as h approaches 0 of f at x plus h minus f at x over x, provided that this limit exists. This is called Newton's quotient, and if we are asked to find the derivative of a function by first principles, this is what we will be doing. There are many ways to denote the derivative of a function. Principally, we have Lagrange notation, Leibniz notation, and Newtonian notation, but it is less common. In general, it depends on how you are given the function. So if your function is expressed in function notation, so f at x, you will use Lagrange notation f prime of x to express the derivative. If you are given the function as y equals, then you will be primarily using actually I use y prime less. You will primarily be using the Leibniz notation. So to read it, this is f prime of x, and sometimes you'll see y prime of x. The notation's nice and brief, but it does lack some detail. The Leibniz notation is read as dy by dx, or the derivative of y with respect to x. Gives some more detail in that it gives both variables, and it also has a few variations. You can do df by dx or d by dx of f at x. That emphasizes the function. And this is how we use the notation to show that we're finding the derivative at a given point. So as we do the next examples, just pay attention to which notation I'm using and how. And let's get into the derivative.